Warm wind blowing over the earth, sky blue. I sing through the land sings through me, sky blue. Reaching into the deep shade.
Okay, here's an odd little section, 2.4 on rational and irrational numbers. It's kind of a review from grade 8, 9, even some stuff we've already done in this course. Kind of strange, but anyway, it's not too long, so should be able to get through pretty quick. And it's good because in the next two sections are tough, very tough. So it's good to have a nice, easier one and get us ready for the two tough sections that are coming up. Alright, rational numbers and irrational numbers. We already talked about this, but just as a reminder, rational numbers are any number that can be written as a fraction. And we're talking about radicals a lot, square roots, cube roots, all that kind of stuff. So remember that a rational number, for example, is like the square root or the cube root of any, well, I guess the square root of any perfect square. Or, I'm not going to write it, or the cube root of any perfect cube, or whatever. Those are all rational numbers. Like the square root of 16, that's 4. Yep, that's a rational number. The square root of 9 over 25, that's 3 over 5. So those are all rational numbers. This is all review. I should probably not even bother to do this. Irrational numbers are numbers, they're decimals, and they're non-repeating, non-terminating decimals. Remember, they go on and on forever, but they don't repeat. An example of those, again, relating it to radicals, or specifically to square roots, I guess, it's like the square root of any non-perfect square. Or it's the cube root of any non-perfect cube. Non-perfect square in this case. Okay, so for example, the square root of 15. What's the square root of 15? I don't know, 4 point something, but I don't know exactly what it is. So in these cases, these irrational numbers, when it's not a perfect square, even if you were to use a calculator, if you were to take your calculator and put the square root of 15, I'll do that. I'm doing that right now on my calculator at home. I'm having some troubles though because I forgot to turn it on. If I take the square root of 15, I get 3.872983346. Is that the exact answer? No, that's just an approximation. How long does that decimal go for? Forever. When does it repeat? Never. So I'm not going to write it here, but remember, even a calculator can only approximate the square root of a non-perfect square. Alright, that's what we're going to do. We're going to approximate here, but we're not going to approximate with calculators. We're going to put the calculators away, so I'll do that. Here, I'm putting it away. Hear that? I'm putting it away. And I will approximate some of these without a calculator. Alright, so we're going to decide whether these numbers here are rational or irrational. So we're looking at the cube root of this big number. So remember, we did this last day. If you're doing the cube root of this, what you could do is you could look at two parts of this. You could look at just this first 27, and you could ask yourself, is there a cube root of 27? Is 27 a perfect cube? And the answer is yes, there is a cube root of 27. The cube root of 27 is 3. And the next thing you could do is you could look at all these zeros, count up all those zeros. 1, 2, 3, 4, 5, 6, 7, 8. Did I count that right? No, I missed this one here in the highlighted part. There's actually 9 zeros. So if we're looking for a cube root, that means we want a number times a number times a number that gives this whole number in here, the whole radicand. Okay, well, we figured out that the cube root of 27 is 3, so it would be 3 times 3 times 3 to give the 27 part. Now, if we have a total of 9 zeros, how many would we have here, how many would we have here, and how many would we have here? You'd need to have a third as many in each spot. So you'd have to have 3 here, 3,000, 3 here, 3,000, and 3 here, 3,000. If you were to multiply all those together, it'd be 3 times 3 times 3, which is 27, and then you'd have 3, 6, 9 zeros, and that's exactly what we have. Remember, if it's a cube root, you need to be able to take all the zeros and divide it by 3. If this wasn't a cube root, if this was a square root, you'd need to have an even number of zeros. You'd know for sure that this is not a perfect square here. But in this case, it is a cube root, and it does work. So this number here is a rational number. Rational. And just so you're clear, the cube root of this huge number here is 3,000. It's not what the question's asking you, but just so you're clear. Okay, next one. Square root of 1.21. So one thing you hopefully notice is that the square root of 121, which is kind of what this looks like, 121, just move the decimal. What's the square root of 121? 11. But in this case, we're looking at decimal places here. How many decimal places are there? There's 2 decimal places. 2 decimal places. Well, if we multiply, remember with square root, you're looking for something you multiply by itself to get this number. Is 11 times 11 121? No. We want to end up with 2 decimal places. So how many decimal places should we have in our answer? We should have 1 decimal place. So the answer is 1.1. Does that make sense? Because 11 times 11 is 121, and if you have 1 decimal point and multiply by another decimal point, you end up with 2 decimal points. So you end up with 1.21. This is a review from grade 9, so I'm hoping I'm going through this quite quickly, but I'm hoping you remember this. So kind of similar, when you have the big numbers like this, and we're talking about square roots, you need to be able to divide the zeros in 2. But when you're talking about small numbers with decimals like this, you need to be able to divide the decimal places in 2. When we're talking about cube roots and they're big numbers, you need to be able to divide the zeros in 3. When we're talking about cube roots and we have little decimal numbers, you need to be able to divide the decimal places in 3. Okay, hopefully that makes sense. Okay, in this case it works. The square root of 1.21 is 1.1. This is another rational number. Okay, the next one, 4.9. Again, hopefully you realize that 4.9 is close to 49. It's kind of the same thing. Not close to it, but it looks like it. What's the square root of 49? 7. Okay, we're looking for square root. So if there's only 1 decimal place here, we need to have half as many. We need to have half a decimal place. What? Half a decimal? You can't do that. This is not rational. It doesn't work. This is wrong. This is irrational. There's no rational number that you can multiply by itself to get 4.9. Last one, cube root of this. Okay, well look at, we have cube root, that's a 3, cube root of 125. I believe 125 is a perfect cube, is it not? What multiplies by itself 3 times to get 125? 5 times 5 times 5 equals 125. So that takes care of this bit. Now we have to look at the decimal places. How many decimal places is all this? 1, 2, 3, 4, 5, 6 decimal places. Well, if our answer, we're looking for something that you multiply by this and multiply by the same thing, and it's 5, 5, 5, we want to end up with 6 decimal places. So how many have to be here, here, and here? Remember what to do? Divide it in 3. We should have 2 decimal places here, so 0.05, 2 here, 0.05, and here 2 here, 0.05. So the answer is 0.05 or 0.05. Yeah, it worked. This was a rational answer. Okay, between what 2 consecutive numbers is the square root of 33? Here's where you need to remember that list of numbers. Remember those perfect squares? 1, 4, 9, 16, 25, 36, 49, 64. Why are these numbers so special? Because they're perfect squares, which means it's really easy to figure out what the answer is of the square root of 1 and square root of 4 and square root of 9. These all have perfect whole number answers. So what we're interested in is the square root of 33. Where does the square root of 33 fit in here? Well, 33 is between 25 and 36, so the square root of 33 sits right in there. Alright, what is the square root of 25? 5. What is the square root of 36? 6. So guess where the square root of 33 lies between? It lies between 5 and 6. The answer to the square root of 33 is 5 point something. In other words, it's between 5 and 6. It works as well with cube roots, but with cube roots, of course, you're using different numbers. What are the perfect cubes? 1. 0 is also a perfect cube. I guess I could put it. Same with back here, right? I guess I could have put 0 down here. Square root of 0 is 0. Anyway. 1, what's the next perfect cube? 8, because 2 times 2 times 2. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And we're gone more than far enough. Because we easily can figure out the cube root of this. We can easily figure out the cube root of this, cube root of this, cube root of this. We have perfect whole number answers for these. Cube root of 40 is not a perfect cube, but where does it sit? It sits between 27 and 64. So the cube root of 40 is in here. What is the cube root of 27? 3. What is the cube root of 64? 4. So the cube root of 40 is between 3 and 4. All right, let's take it one more step. Now we're going to approximate to one decimal place. What's the square root of 62? We did this if you're in my class. I don't think any of you were, but we did a lot of this in grade 8. So what you're going to do is you're going to start by doing this exact same thing, and then we're going to take it one step further. So square root of 62. So again, think of some of those square root numbers. We have to get up above 62. So they go 1, 4, 9, 16, 25, 36, 49, 64. Oh, we made it. Here's the one. So all we really care about, you don't need to write all these, right? If you can just pick the ones that are just a little bit above and a little bit below, you've got it. We know what the square root of 49 is. We know what the square root of 64 is. The square root of 62. Now, the square root of 62, does it sit closer to 49 or closer to 64? Way closer to 64, so it's somewhere way up here. What's the square root of 49? 7. What's the square root of 64? 8. So we know it's 7 point something. It's always going to be the lower one, 7 point. Take the lower number, 7 point. But now, root 62 is closer to 8. So why do we know for sure that it's more than 7.5? Because 7.5 would be right in the middle, and this is closer to the 64. Closer to the 8 if you want. The answer has to be closer to 8. So I would say that the answer is 7.8 or 7.9. I think either one of those answers is a really, really good estimate. I'm not asking you to find it exactly. If you want to know what it is exactly, then I put it in your calculator, you'll get something like 7.874. And in fact, is even that exact? No, remember, these are all irrational numbers. This is just an approximation. But you can see it's 7.874, which rounds to 7.9. Either one of these would be a great answer. 7.5 would be wrong. Anything below that would be wrong. 7.6 is really not a very good answer. 7.7, I'd probably have mercy on you, but I think we could get a little close. It's really close to the square root of 64. So I think it's one of those two for sure. Approximate the cube root of 10. Okay, we've got to write down some perfect cubes. 1's a perfect cube, 8's a perfect cube, 27's a perfect cube. Oh, we've already gone above 10. We've got all we need. We really don't need the 1. So cube root of 8 and cube root of 27. And what we're interested in is cube root of 10. Oh, that sits way down here, much closer to this than it is to that. So the cube root of 10 is down here. What's the cube root of 8? 2. What's the cube root of 27? 3. So we have an answer. Remember, you take the small number, so 2 point has to be between 2 and 3, so 2 point. It's much closer to 2 than it is to 3. For sure it has to be less than 2.5. 2.5 would be right in the middle. But it's really close. I mean, it really is quite close to this number. I think 2.1, 2.2, or 2.3 would be a really good answer. Personally, I'd probably go with 2.1 or 2.2. I'll go with 2.2. Want to know what the calculator says? It says 2.1544, which rounds to 2.2. But remember, I don't care about this. I want you to be able to get an estimate. If you didn't say 2.2, but you said 2.1, awesome. If you said 2.3, great. If you said 2.4, not so good. If you said 2.5, wrong. 2.6, wrong, same like all that. Okay? I just want you to be able to get some estimates like this. Nothing doesn't have to be exact. Put the calculators away and do your estimating. That's it. We're finished. Is that the shortest, kind of strangest section ever? Yes, I think it is. Okay. Enjoy it, because the next 2 days, especially the second day from now, hoo boy, it is tough. We'll do it over 2 days though. Okay, enough of that. Have fun. Take care. Bye.
So tired of